Kubernetes and GKE Part 32. This episode has 4 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. What is Admission Controller? Here's a strong way to approach it. An admission controller in Kubernetes is a plugin that intercepts requests to the Kubernetes API server after authentication and authorization, and either allows, modifies, or rejects them before they are persisted in the cluster. Core idea: admission controllers act as a final checkpoint before a resource, pod, deployment, etc. is created or updated in the cluster. Think of it as a gatekeeper that enforces policies after login but before saving changes. Why admission controllers are used: they help to enforce security policies, validate resource configurations, automatically mutate requests, prevent misconfigurations, ensure compliance standards where it fits in Kubernetes request flow. Kubernetes API server authentication, authorization. Admission controller acts only after passing. Admission controllers is the object stored types of admission controllers. 1. Mutating admission controllers modify the request before it is saved. They can add default values, inject sidecars, e.g., service mesh proxies, modify resource limits. Example: automatically inject Envoy sidecar in a pod. 2. Validating admission controllers validate and approve or reject requests. They can reject unsafe configurations, enforce security policies, ensure required fields exist. Example: reject pods running as root, enforce resource limits. Example use cases: 1. Security enforcement, block privileged containers, enforce non-root users. 2. Resource control, ensure CPU or memory limits are set. 3. Policy enforcement, restrict images from untrusted registries. 4. Defaulting behavior, auto-assign namespaces or labels built in admission controllers. Examples: namespace lifecycle, limit ranger, resource quota, pod security, default storage class. Custom admission controllers you can build your own using admission webhooks, mutating webhook configuration, validating webhook configuration. These call external services for decisions. Example: validating webhook flow, API server, webhook service, allow or deny API server. Simple analogy: think of API server equals building reception, authentication equals checking ID, authorization equals checking access rights, admission controller equals final security inspection before entry. Key characteristics: runs inside API server, request life cycle, can modify or reject objects, works on all Kubernetes resources, critical for policy enforcement. Difference from RBAC feature: RBAC admission controller purpose, who can do what is allowed to be created. Stage authorization, post-authorization scope, user permissions, resource validation or modification. Best practices: use admission controllers for security enforcement, combine with RBAC and network policies. Use validating webhooks for strict policies, use mutating webhooks for defaults and injection. Interview ready definition: an admission controller in Kubernetes is a policy enforcement mechanism that intercepts API requests after authentication and authorization to validate, mutate, or reject objects before they are stored in it, enabling security, governance, and configuration control within the cluster. Nice. Let's continue. Question 2. Explain OPA Gatekeeper. Here's a strong way to approach it. OPA Gatekeeper is a policy enforcement framework for Kubernetes built on top of Open Policy Agent, OPA, that allows you to define and enforce custom governance and security policies for Kubernetes resources. Core idea: OPA Gatekeeper lets you define rules for your cluster and automatically enforce them at admission time. It acts as a policy engine that blocks or audits non-compliant Kubernetes resources before they are created or updated. Why OPA Gatekeeper is used: Kubernetes alone does not enforce advanced business or security rules like all pods must have resource limits, no container should run as root, only approved container registries are allowed, every namespace must have labels. Gatekeeper solves this by adding policy as code, enforcing organization-wide rules, providing audit plus enforcement capabilities. How it works: OPA Gatekeeper integrates with the Kubernetes API via admission webhooks. Kubernetes API server Gatekeeper webhook, allow or deny it. Key components: 1. Constraint template defines the policy logic using Rego language, OPA language. Example: deny privileged containers. 2. Constraint applies a policy to specific resources or namespaces. 3. Admission webhook intercepts API requests and evaluates policies. Example policy: step 1. Constraint template API version. Templates: Gatekeeper SH or V1 kind. Constraint template metadata. Name. K8s require red limits spec. CRD. The exact commands and code are in the written question bank. Great. Moving on. Question 3. What is Kyverno? Here's a strong way to approach it. Kyverno is a Kubernetes native policy engine used to validate, mutate, and generate Kubernetes resources using YAML-based policies in Kubernetes. It is an alternative to OPA Gatekeeper, but is designed to be simpler because it does not require a separate policy language like Rego Core IDEA. Kyverno lets you write Kubernetes policies using plain YAML instead of a custom language. It works as an admission controller plus policy engine. Why Kyverno is used? It helps enforce cluster-wide rules such as require resource limits on pods, block privileged containers, enforce image registry policies, automatically add labels or annotations, generate resources like network policies. How Kyverno works. Kyverno integrates with the Kubernetes API server using admission webhooks. Kubectl API server. Kyverno allow or deny or mutate. It evaluates policies before resources are stored. Key features of Kyverno: 1. Validate policies, accept or reject resources based on rules. Example: block containers running as root. 2. Mutate policies, automatically modify incoming resources. Example: add labels, inject default resource limits. 3. Generate policies, automatically create additional resources. Example: create network policies when a namespace is created. Kyverno policy structure. Kyverno uses pure YAML, making it easy for Kubernetes users. Example: validation policy, API version, Kyverno IO or v1 kind, cluster policy, metadata, name, require limits, spec, validation failure action, enforce rules, name, check resources. The exact commands and code are in the written question bank. Alright, next question. Question 4. Explain mutating webhooks. Here's a strong way to approach it. A mutating admission webhook in Kubernetes is a custom admission controller that intercepts API requests and modifies, mutates, the object before it is stored in the cluster. Core idea: a mutating webhook edits Kubernetes resources automatically before they are created or updated. It allows you to inject defaults, sidecars, labels, or configurations without changing application manifests where it fits in request flow. Kubectl API server authentication authorization. Mutating webhook validating webhook at mutating webhook runs before validation changes are applied first, then validation ensures correctness. Why mutating webhooks are used? They help to automatically inject sidecars, e.g., service mesh proxies, add default labels or annotations, enforce standard configurations, inject environment variables, attach security or monitoring agents. How it works: 1. User sends a request, pod, deployment, etc. 2. API server forwards it to mutating webhook. 3. Webhook evaluates the object. 4. Webhook returns a JSON patch. 5. API server applies modifications. 6. Object proceeds to validation stage. Example use cases: 1. Sidecar injection, automatically add envoy proxy for service mesh, Istio. 2. Add default labels, metadata, labels. The exact commands and code are in the written question bank. Let's keep going. That wraps up this episode. Nice work practicing, and see you in the next one.